Hey grads, the old shop teacher chief here on a cold winter's New England day in the shop again, making the best of it. At least it's not 7 degrees out there. It's about 34 degrees today. Um, just sticking to a promise for me. Every day I try to do something, get up and move, exercise. I don't care if it's running, hiking, swimming, getting in the gym. It's the three-legged stool, which is strength, cardiovascular, endurance, and flexibility. So each of those three legs, if one of them is missing in your workouts, your stool falls over. So maintain a balance of strength, endurance, and flexibility, stretching. We have a shelf life for our shoulders, our elbows and knees and backs and so forth, and hips. So take care of your body. It's the only one that you have. They're not going to reissue a new one. So I know you folks are out there. I want to touch base with the old shop lessons that we share together on the concrete floor. I know you folks are iron workers and boiler makers and pipe fitters and sheet metal workers and millwrights and pile drivers and self-employed and shop fabricators and blacksmiths and so forth. But it's really important that you understand that you have an old gray-haired shop teacher. My hair color is a little bit different than yours, a little bit knowledge, a little bit of wisdom, a little bit more mistakes and experience. So if you ever need a question, text me or email me or call me, and we can meet up in this small little steel shop that I have. So if you're looking to increase your welding knowledge and skill set, and you need to go for a job interview, and we need to talk about job interviewing, what to ask, portfolio making again, I'm here to help you. So please think about that, okay, folks? The last thing I want to say before I get into the lesson is your note taking. It's so important to have a small notebook, fits in your pocket, your back pocket, in your toolbox, wherever it might be. Always taking notes. Could be, qualification information on welding, and it could be on your flux core, your parameters. It could be material science. It could be geometry and formulas laying out. Just keep a notebook handy on your person, whether you're in a job site or in a shop, to make sure you understand that when you jot it down, now it's permanent. So if you're just talking, sometimes it swims around in your head, and then it just drifts away. Other things happen during the day, and you forget. If you're taking courses, I've always been an advocate and emphasize how important note taking is to you folks. So I'm always constantly learning and taking notes on welding. This happens to be a WPS, an engineering type course that I took. So it's important that you understand that you need to solidify what you're learning, and it's usually done with a pencil or a paper or soapstone. I'd like to go back to chemistry. This is what the world is made up of, the universe and the rock that we live on. But most importantly, this is the gases that we use in welding, the materials that we are about to weld and fabricate and bend, the filler wire. It's so important to understand basic chemistry and what goes on and how it can go wrong and how you can retrace your steps. So think about that, okay, folks? I want to reach back to a book that a mentor gave me not long ago. The book was published in 1927, and it was about metallurgy and making steel. But they had this diagram, and I thought this was invaluable in terms of the carbon content in steels. And if you look here, those little bursts right there are the carbon bursts. So the higher the carbon, the more burst you're going to get. They're like little spurs, if you will, okay? So if you look over in here, that's a low carbon, and wrought iron, they basically almost have very little, okay? But if you come across metal in a shop, you're an owner or a fabricator, you're on a job site, and just mysterious metal that you don't know what it is, take a grinder to it and look at the and do an evaluation on those little sparks and those spurs that come off. If you got a lot of them, you know that if you just go and weld that with no preheat and no post heat, that you're going to hear a crack. With that said, most of the steel that we weld and fabricate, maybe almost 90% of it is like A36 or 1020. So it's very, very low carbon steel. And the lower the carbon steel, the higher the ductility, okay? But carbon adds toughness and strength to it, right? So stress equals strength, okay? So we need stress in the molecules, okay? That's a whole metallurgy lesson. But we need the carbon content to make it stronger. For example, remember we reached back, we used to make center punches, and we used to make a scribe, and we would forge it, and then we would heat treat it? Same thing. This material here is not the same as this material here. So it has a higher carbon content. This is like a 1090 steel. This is a 1020. So it's 0.2. This is 1084. It's a 0.8. So if you notice the numbers are increasing, it's the carbon content that is increasing. So if you're puzzled and you don't know what the material is, take a file to it. If the file bounces right off of it, that means the material is as strong as the file. Take a grinder to it and do an evaluation. Send me your address. I'll send this to you, and you can put that up on your toolbox or your shop, or keep it on your person. It's really important to understand what carbon does to steel and how it can make it strong and how it can make our life upset if we don't follow certain parameters when we're welding it. Please keep that in mind, okay? So with that said, I wanted to do a little science evaluation here. So we know that if you take aluminum, we know that it's non-magnetic, right? It has no iron particles in it, right? We know that if we take regular mild steel, which is that 1020, 1010, A36, we know that it's got carbon and it's got iron in it. So it's the iron that is critical. So if I take my torch and I heat this up, and it's called quenching. So if I do that with the carbon and the iron molecules, right? I'm going to make that into a martensite, brittle, okay? So I'm going to make it stronger, okay? But less ductile and less malleable, if you will. But if I take some non-ferrous material, right? Ferrous meaning iron particles, and I heat this up again, right? This is my aluminum, as the English say. And if I heat this up, has no iron particles in it, right? And if I quench it, I soften it. So the point I'm trying to make is that when you have iron and carbon in ferrous material, when you quench it, you make it harder, okay? You make it into a martensite structure, if you will. But if you have aluminum, bronze, copper, and you heat that up and you quench it, you anneal it, meaning soften it. So it's important that you understand that large grains are ductile and tight grains are strong and brittle, okay? So in heat treating, when we did our center punches and scribes and chisels that we made, we had to heat treat that. And I'm going to do a lesson about heat treating a tool. So you know that at this point, a tool like that has got 0.9 carbon content. You can make a chisel out of that. It's a tool already, but you have that carbon content to make it strong, and then you would heat treat it. Here I have an old piece of wrought iron, which is from the 1800s. which is basically no carbon at all, okay? So very soft, so very ductile, very malleable, if you will, okay? So you need the carbon content and other alloying ingredients to make it stronger. You know that when you have regular 10, 20, or A36 steel, mild steel, you can shape it and bend it and make all kinds of neat things with it, like we do in the shop for fun, but it's much more forgiving. But if we're looking to make a tool out of this, it doesn't have enough carbon in it to make the tool. This is rebar, which is like sort of a low to medium. You can make a knife out of it. You can make a blade. You can make, a tool out of it. But it's not like if you have 1084 steel, if you have high carbon steel. So folks, I want you to think about that. Think about the lessons that we learned together, the time we spent on the shop floor, the time that the chief had endless lessons and soapstone diagrams and note-taking and food for thought, if you will. I just would like to implant the emphasis and the need to continue to learn, continue to take notes, continue to take courses. Maybe you become a CWI, maybe you become an NDT person, but the journey is the beginning, the middle, and we hope it continues. So it's a never-ending journey of learning and developing your skills. 45 years later, Chief is still at it in his small little sheet metal welding blacksmith shop that he has here in New England. All right, folks, I just wanted to touch base with you. That was another series, and we have more to come from here. So stay tuned. Okay, over and out.